Welcome to part 3 of the Pavlov modding series. Today I'm going to be taking you through a game mode setup from scratch. We're also going to be covering some level actors such as a buy area, a jump pad, a boost pad which will increase your walk speed, teleporters. We will also cover the setup for pickup actors as well as spawners in the level. We'll cover some widget replication as well to show the winner, and this will change based on if it's team deathmatch or deathmatch. And then we will create a player info component. This will be a component that stays with the player for the course of the round, or the course of the entire match basically, until the server rotates to the next match or it goes back to the lobby. So we've got a lot to cover in this video, so let's get started. Okay, so the first thing that we need to do is go up to Window, Pavlov Workshop, and Create New. This will create a new UGC folder for us to store all of our actors as well as our materials and assets that we'll be using on our project. So if you click your tree view here, you can see that you have your custom maps folder, then you have your UGC. And it'll automatically create a definition. I'll be covering the definition here shortly. So next we're going to hit Save Current. This will save the map that we're currently looking at. And I'll call this our test map. You can double click it to open it. We technically already have it open, but I'd just like to go ahead and do that. Now let's go into our definition, select our map, our test map. We'll drop down our mix flags, and for our custom game mode it's going to be team deathmatch and deathmatch. And we are going to tick custom as well, and then we want to tick custom game mode, and this will be coins is what I'm going to call it. I'll explain a little more on the game mode later, so don't worry too much about that for now. And to start, I'm going to use a landscape. I'm going to set it at 0. I'm going to hit create. This will put a landscape in the level for me, and I'm going to add a directional light. And then from there we could add some Pavlov spawns. Set 1 to -1, dynamic. Set 1 to 0 for team 0 and 1 for team 1. That way we have a spawn point for each team that is possible. We'll also go ahead and add a kill volume underneath the level. And I will set this to 60,000 by 60,000. I just know that that's big enough for the landscape, or it'll extend over it. And I'm just using a landscape as well because it's easy to get going for a test map. So now let's create a new folder. We'll call this Blueprints. And we'll create a new blueprint class. And for this we'll go and drop down all classes, and we will search for a game logic, and we will use the Pavlov game logic, not the example. So we'll call this game logic coins. We'll open this up and we'll set our definition from the drop down. Now let's drag this game logic into the level. You need to have 1 in your level. And from there we can go ahead and create some subfolders that we'll need. So we'll call this level actors, pickups, and then we're also going to need another subfolder under our UGC called art. And I'm just going to import some meshes very quickly. So you should have a model source folder, and we'll import all of these meshes from the model source folder. And they should have collision, so we don't need to auto-generate collision for them. And we'll import all. Oops, drag them all out at once. You can see they're just very simple models for you to use for this project. This will be a coin that we'll use for our game mode. This will be a health pickup that will rotate in the world like this, and you'll be able to walk over it and collect health. This will represent our jump pad, and this will represent our teleporter, the area that you walk through. Alright, let's save all of that. From here we'll start moving on to some scripting. I'm going to kind of go about this quickly, so I do apologize if I'm moving somewhat fast, but I need to cover quite a bit of information in a short period of time, so I'm going to do my best to fit it all into maybe an hour or less. And if I can do that, then I can cover some bonus information as well. So let's get started on the scripting. So let's navigate to our blueprints folder, go to level actors, and we will create a new actor. For this we're just going to use actor. So this will be BP underscore level actor. And this is going to be our parent class, and I'm going to be showing you guys a little bit about inheritance. The main reason we're going to be doing this is so we don't have to create 5 actors and set them up all the same way. They're all going to be doing basically the same thing as far as what components they have and how we interact with them. So we'll just set up one actor that deals with the main interaction portion, then we'll create child actors that cover the interaction for each of those child actors. So I'll show you how to do that. To start, we're going to add a static mesh. This will be the mesh that represents our level actor. And for this I'm just going to pick our jump pad just so we have some sort of default mesh. Next we're going to be adding a box component, box collision. And we will go and scroll down, find our collision presets. We'll set this to custom. We'll set everything to ignore by ticking this, and then we will go down to pawn, and we want to set only the pawn to overlap. So basically we're going to generate an overlap event whenever the pawn walks over this box. Now we need to resize this a little bit for this static mesh, just so we cover the top of this pad that we're going to be using. And that'll be good. Now if we go back to our event graph, we can scroll down to on component begin overlap. That's once again with the box collision component selected. We'll click begin overlap. This will generate an event for us. And what we're going to be doing with this is taking other actor and casting it to character. We only want to interact with this if we're a pawn. A character inherits from pawn, so that'll allow us to get anything that's related to the character and use it, so we know which character has overlapped the box, who has walked over it. Now with this we're going to create a new function. So what I'll do to make it easy is we'll add a reroute node off of character, and I'll do another one off of the execution pin. And that way we can highlight both of these by just clicking and dragging. Right click on the box there and collapse to function. We'll call this character overlapped. And with this function clicked, if we come over here on our right panel, we'll see it already created our input for us with the character parameter. And we'll call this character. So now on any actor that we create that is a child of this actor, it will also have this character overlapped function. And what we could do is we can override this function with our action that we need to do whenever the character overlaps it. So let's go ahead and create our first one now. We'll call this LA for level actor, and we'll call this jump pad. We'll go to our event graph and we will override that function like I said. And there we go, we have our character input. And what it does is it goes through this portion of our event graph, calls character overlap, and then that runs on our child actor. So what we want to do for this jump pad is when they overlap it, we want to send the character flying in the air. And so what we're going to do is we're going to add an arrow component. And I'll rotate this so it's facing up. And this arrow will basically determine the direction that we want to send the player. So if you wanted to tilt it forward and to a certain direction, you could do that here. I could also show you how to expose a parameter that will change that for you. So what we will do is drag from the arrow, hold down Control, and that'll drop a get node. So from the arrow we want to get the forward direction or forward vector. And then we want to multiply this by a float. And this will essentially be our boost value that we want to apply. So let's drag off of the float pin and promote it to a variable. We'll call this the boost, or just boost. And we'll come over here and we will tick instance editable with the variable selected. This will allow you to edit it in the level. Say if I drag this out, we see here we have boost right there. So let's give this a default value of 2500. That'll be a decent starting value to send them flying. And what we want to do here is drag off of our execution pin and type switch has authority. This will gate this off to do it on either authority, which is generally speaking the server, or client side. And for this we need to do it client side. We will call launch character. We will pass in our vector, the launch vector that we created. And we will override our X, Y, and Z value. This will basically give them a new velocity, a new launch velocity. And now we could do one more thing. We could create another variable and we'll call this angle. And we will set this to be a float and instance editable. And what we'll do is go up here in the construction script and we will set our relative rotation and for this we will split the struct pin and then we want to pass our angle into the pitch. And we'll set this to 90 to start and I'll show you what this does. So we could come click on our actor in the level and we could change this pitch or our angle and you'll see that changes the pitch of the launch velocity that we're going to give them. So I'll give you a quick way to adjust which direction it's pointing. So that pretty much takes care of our jump pad. One thing that we should check is that the static mesh in our level actor, the parent, we want to set that to block all. And that'll just make sure that it blocks everything. You could also set it to static as well, since this won't be moving. Now we could go ahead and close out of those. And we will create another one, another child actor class. And to do this, if I didn't cover this or show it well enough the first time around, you click your parent class, the level actor that we created, right click, we create child blueprint class. And we will create the level actor teleporter. Now we need to swap out the mesh for the teleporter, use the portal mesh provided, and we also need to go ahead and move the box component. So we'll shrink our Y down and we will increase it in Z. Next we will add a capsule collision. And this will be the teleport location that we want to send the character to. So when they overlap with the box component, we'll send them to this capsule's location. And I need to grab some values really quickly for the capsule. So this will be 88 in the half height and 34 in the radius. And this is just a generic spawns general value. So we'll use that. And we want to make sure that when we're placing this in the level that this capsule does not overlap with anything. So I'll go ahead and show that very quick. We drag this out. We'll have our capsule here that we could teleport to, and the way we edit its location is we select the actor in the level, we go over to its components, we select the capsule component, and then we can move it within the level. Should note that you definitely do not want to teleport them right into a teleporter. Make sure that where you are teleporting them to is outside of the teleporter box, the overlap box. So let's go ahead and set that up. This one's fairly straightforward. So we're just going to do non-character overlapped. We're going to override it once again. We're going to do a switch has authority, because we only want this to run on authority this time rather than client. Or we don't need to do a cast here. We need to call teleport. And we want to get our capsule's location. Get world transform. We'll come over to our transform and we'll split the struct pin. And that's all we need to do for teleporting. So next, we're going to go on to one that will require a component that will get added to the player or the player state, either or. We're going to go with the player state. We'll be adding it to that for our game mode. But this component will keep track of the player's movement speed. So when they overlap a boost volume, it'll increase their movement speed for a set duration of time, and then it'll set it back to the normal movement speed value. So let's create the actor first. So be LA boost pad, or we'll call it speed boost actually. And for this one we will override the function once again. We are going to need a switch has authority because this is going to replicate in a different manner. I will show you the whole setup for this a little bit later on because we're going to actually need to create the component. So let's go ahead and do that now. Let's go over to our blueprints folder. We'll create another subfolder called components. I'm just going to abbreviate it. We'll create a new blueprint class by right-clicking, and we will create an actor component. This can contain basically a script that you could reuse for actors, so you could add the component to them, and then you could reuse it. This will not contain a transform, unlike a scene component. So this will just contain script information and basically variables that will stay with the player. So we will call this component player info. Now let's open this up. We're going to first start out by looking at the class defaults. We do not need tick enabled, and we want the component to replicate. Next, we're going to need a variable for our speed boost value. So we'll call this our walk speed. We'll set this to a float, and we'll set this to rep notify under replication. And also for your replication condition, this could be set to owner only. This means that it only cares about replicating this variable to whoever owns this component. We will also need another variable for this, the pawn. You wouldn't technically need this variable, but due to how I'm going to be setting this up for the project, just go ahead and make this and follow along. Basically, I'm going to be adding this to the player state, this component, rather than the pawn as I covered earlier. If you were just going to be creating these level actors and not the game mode and the full setup that we're doing today, then you could go ahead and skip the pawn, and essentially you would add the component to the pawn, and then you can get the pawn by doing get owner, cast to character, or cast to pawn, either or. But we are not going to be using that setup. So because we created walk speed with the rep notify, it created an onRep walk speed function for us. And also, very quickly before we go forward, we need to set the pawn to replicated. But let's go ahead and go into the walk speed function here. And what we need to do is get our pawn, get pawn, or you could hold control when you drag out. We're going to click the variable, right click it, convert to validate get. So basically this will check if this is valid. It's just easier than doing something along these lines. If the pawn is not valid, we obviously don't want to try and get any information from it because it's a null pointer at that point. So what we're going to do is from the pawn, we're going to get the movement component. We will cast this to the character movement component. And this will allow us to access the character's movement variables. And what we want to do from here is set our max walk speed. This will basically be our maximum speed that we can run. It's not technically walking. This is only when you're sprinting. This will be the max speed that you will walk. It's kind of a tongue twister, walk and run, so many different spots, but yeah, it's your run speed. So let's go ahead now and create where we're actually setting this walk speed. So let's create a new function and we will call this boost walk speed. And we're going to drag out our walk speed, hold Alt, which will drag out a set node rather than a get node. And we need to set our walk speed. So to do that, we're going to drag this over our function and this will create an input pin for us. And we also need one more, so we're going to click the input and we're going to click new parameter. We'll create type float and this will be the duration. What we're going to do is we're going to set up a timer that after the duration of time has passed will set the walk speed back down to the normal amount. So we'll go to our event graph. We'll create a custom event. This will be reset walk speed. We will set timer by event. We'll drag off of our event pin here. You can type custom event. And this will be default. Set walk speed default. So now we want to drag our time up to this reset walk speed there. What we're going to do from here is set the walk speed to the default, and that would be 350. And also make sure that you go ahead and set that as your default in your parameter as well for your walk speed. Next we need a function to initialize this component so we can set these variables to begin with. So we'll call init player info function. Drag out our pawn and set. You could hold Alt once again to drag it out and it'll create the set node. And we will pass these into the input for this function. And also what we're going to need to do when we originally add this component, we need to go ahead and initialize it client side. So we're going to create a custom event for that. This will be init player info client. This will be run on owning client, reliable. What we will do here is, I'm just going to drag this out to make it easy. I'm going to pass in a walk speed param, a pawn param, and we will say is valid. If this is valid, then we will get the movement component, cast to character movement component, and set max walk speed. And this will just allow us to initialize it client side as well. Rather than waiting for it to replicate down, you could call that event for it to replicate down right off the bat. And the reason why we replicate it this way is for later down the line, if they walk over the component, the boost speed, it'll just change this value, and then that'll automatically replicate for them. So if we wanted to give them a different default walk speed, that would allow it to get set right off the bat. Now what we need to do is go up to our init player info and call init player info client. This one will run on the server. I don't have the suffix, but we could do that. And the other one will run on the client. Now we just need to pass the variables into player info client, the init. Go ahead and compile and save that. And then from there we can move on to our speed boost actor. Now from here what we want to do is add a switch has authority because we only want to do this server side. We're going to get component by class. And we're going to look for the component player info. If only I could type right now. Now we want to check if it is valid. And I'm using the second one with the question mark, the macro versus the function. Now if it is valid, then we want to call boost walk speed. And what we can do is promote both of these to a variable. We'll call this boost speed. We'll set it to be instance editable. And we'll set this up to be, default's 350, we'll do 600. Should be good. And we'll give them the boost speed for, say, 15 seconds, which we can also promote to a variable. Boost duration. If we hit compile, it'll show us the default value. 15 seconds. We'll set this to be instance editable as well. So that means you can have multiple boost pads, speed boosts in the level, and you can set different values for each. You can correlate their color to how much their boost value is and the whole nine. So there's a lot that you could do, a lot of flexibility here. Now I'll show you how to add the component to the player. So let's go back to our speed boost, and if it is not valid, what we want to do is drag off of the character pin. We want to add component player info. We'll hook that up to is not valid. We want to init the component to pass them the references. The character will go into pawn. Our boost speed will go into our walk speed. And we are also going to call boost walk speed. This will trigger the timer to get started, so it will reset properly. So what we'll do is pass our boost speed into walk speed, pass our boost duration into duration. We will change the setup later down the line, but for now let's just keep it in a working order. So let's move on to the by area. So let's create a new child actor, LA by area. And for this one, we're going to do things a little bit differently. On begin play, we will do a switch has authority. We will delay for 1.5 seconds. Should be enough time to make sure that all of the actors have initialized already. And we will get all actors of class. And this will be game logic. And we could use our game logic that we've created if you're going to be using a custom game mode, or you could just use the Pavlov game logic. For ours, we'll just use coins since we're going to be using a custom. Then we will do is valid index branch. If 0 is a valid index, meaning we found something at slot 0, then we're going to set it to a variable because there should only be one in the level, so slot 0 is where it would be located. So we'll promote this to a variable, game logic. Now what we need to do is override our function, character overlapped, add a switch has authority, so this is running on the server. Right now this actor isn't replicating, so this variable isn't replicating, nor have we set it to replicate obviously. So we could only run this on the server since that's where this variable is also set. So what we will do is, if it is valid, we will set buying enabled, I believe it's called. Set player buying enabled. What we need to do here is get the player state. And we also want to make sure that the player state is valid for this player. And you could set the duration to whatever you'd like. We'll set it to 60 seconds. I don't see why they would idle in the location longer than that. And then we will set it to, say, 1,000 units should be fine. And what we are also going to do is set it up so when they leave the area, the overlap volume buying is disabled. So what we need to do there is click our box component, go to end overlap, and we will create an event. We will cast this to character. We will also add a switch has authority here. And then we basically can copy paste this over. Pass that in. And then we want to set our duration to 0.5 seconds and we'll set it to 10 units. So once they move, basically once 0.5 seconds have passed or they have moved 10 units, then buying will be disabled. So you could set your static mesh to be a building exterior, and then you can make your box volume the size of the interior of it, and then that'll basically be like a shop on your map. When they walk into it, they'll be able to buy. When they leave, it'll remove buying from their pawn unless you have it set in the game mode to override these settings for some reason, but it should still remove buying from them regardless. And what I could also show in this case is how we could do sounds. We would technically have to set this to replicate, but you could also set up some sounds when they're on the remote side, when they overlap, when the character overlaps. So let's do that really quickly. I don't have any to plug in, but you guys can import your own sounds and set them up. So we will play a sound at the location. We will get our actor's location. And this should destroy the sound when it's done, unless you have it set to looping. If you have it set to looping, then you need to spawn the sound and then destroy it after a certain amount of time. But I would just make sure that the sound you're setting is not looping. You would pass it in here into your sound variable. I'm just going to unhook this for now because I don't have a sound variable to pass in, so there's no reason for me to have it hooked up. You could basically do the same thing over here on the remote side, and you could plug in another sound. Typically speaking, it should pass through all of these checks, so there's no reason to be a client-server mismatch as far as the sounds go, but there's the potential that the game logic might not get set for whatever reason, and then I guess you would typically have a mismatch where they're hearing the sounds but they're not getting their buying enabled. But 99% of the time that shouldn't be the case with this, so you're fairly safe to set it up this way, where remote plays the sound, server side does the action, and that'll take care of it for you. Now it's time to create our first replicated actor. So let's go and close out of these, and we will open up our pickups folder, right click, go to blueprint classes, and select the actor class. We will call this BP_pickup. We'll open up the actor, and the first thing we're going to do is we're going to tick replicates. We are going to set net dormancy to dormant all. This will basically allow it to sit dormant in the level, and you will have to force the replication in order for it to tell clients that variables have updated. That'll just save on performance a little bit. So we will add a static mesh to this, and we'll set the mesh to the health for now, just as a placeholder. And I'm going to move it up a little bit so we could add a rotating movement component. And with this, if we click on it, it has 180 set for the Z. That'll be fine. If you want to speed it up or slow it down, you could change that value, but I'll show you what that does. So we'll drag it out into the level, and if we turn on simulate and hit play, you can see that it will spin in the level, and this just creates a nice looking pickup in my opinion. And it's an easy way to do it, so I figured I would show you guys. Now if we go back into our pickup, we can start out in the event graph, and we will create a couple functions, because what we're going to do with this pickup is we are going to override the function similar to what we did with the level actor. So I'll go ahead and delete some of these things that we will not need. And we'll click on our static mesh. We're going to use the onComponentBeginOverlap, so we'll create the event for it. Now let's also make sure that we have the collision set up properly, so we only create an overlap event when upon overlaps. So the first thing we'll do is change our collision preset to custom, change our collision response to ignore for everything by clicking this top tick box. Then we'll come down to upon and we will set that to overlap. Also, you need to make sure that you have collision set up for all of your static meshes that you use for overlap, or for pickups rather, because you're going to be using the overlap with the collision from the static mesh. So what we will do here is add a switch has authority. We will cast other actor to character. And then we will create our first function, and this will be canPickup. We'll create an output that's a bool, and we will call that canPickup. And we will add an input that's a character. We don't technically need this for what we're going to be doing, but this will allow you to do things such as determine whether or not it should be picked up based on the character's team and things of that nature. So may as well just add it in. And now if we drag this out, we're going to want to use this as a pure function, because we're not going to be editing any information. We're just going to be looking up the player's information with this. So we'll tick pure with the function selected, and you can see now it doesn't require an execution pin, one of these wires. So we'll do a branch off of canPickup. And if we can pick up, we will do once, and this just basically makes it so we could only go through this once, allowing the pickup to only run once per each character that overlaps it, and then once we determine whether or not that character can pick it up, then we'll reset it to be picked up so it can be picked up by other characters if it wasn't successful. If it was successful, then we're going to destroy the pickup. So what we need to do is create a function, and this will be called characterInteract. We'll do a similar setup. We'll pass in the character as an input, and then we will create an output that's a bool, and this will be successful. And now for both of these functions, I want to make sure that the return node is ticked to true by default. So if we don't need them for a child class, it'll just work. It won't default to false and then fail out. So we will call characterInteract after a do once, and we will pass in our character. We will do a branch. If this is successful, then what we want to do is set the lifespan for the actor, and we will set that to 0.25 seconds. If this is not successful, what we're going to do is reset our do once so someone else can try and pick it up. And once again, because we have this switch has authority, it's running on the authority side, which is mainly the server, and we'll do all of this on the server. That's why we are destroying it also here, and we are doing our character interaction here on the server. So we'll be able to do any of our checks that need to add things to variables that need to carry over long-term server side. We'll do that all here, and it'll make it easy later down the road. So now let's go and make our first child actor class. So we'll right click it, create child blueprint class, and we will call this one pickup health. And we don't need to change the mesh since we've already gone ahead and set that up with the last one. All that we really need to do here is we need to get a reference to the game logic for one, so we could add health to them that way. And then for, the second thing we need to do is we need to override the functions that we've created. So can pick up, we don't technically need to override that. Character interact though, we definitely do need to override that function. So we can go ahead and delete the call to the parent. First thing we want to do with character interact is to double check that the character is valid. It should be valid from our cast, but never hurts to double check. Then we want to get the character's player state, so we will get player state. Right click it, convert to validated get. I'll move this node up. If any of these are not valid, then we will return that it is not successful. And we will get the Pavlov player status. Add a branch off of succeeded. We will break the player status because what we need to do here is first get their health, and then we want to add whatever value it is onto it. So let me go ahead and make this a little neater at this point. Move this over. All right. We're going to need a reference to the game logic, so let's go ahead and add the variable really quick. Call it game logic. We'll set it to game logic coins. If you were not doing a custom mod, you could just set it to Pavlov game logic. And let's go ahead and make sure we get that reference very quickly. On begin play, we will add a switch has authority. Off of the authority side, we will do a delay for 1.5 seconds. This will ensure that the pickup has enough time to initialize prior to getting the reference. We will get all actors of class, and we will set this to Pavlov game logic. What do we call it? Coins, game logic coins. There we go. And off of our out array, we will say is valid index. We want to know if the first index in the array is valid. We should only have one in the level, and we're basically asking to get all of them that are in the level. And if it is, then we want to get a copy of it, and that's what we will store as our game logic. Right, and then we want to override can pick up, and if our game logic will get it, convert to validated get. If it is valid, then we can pick it up. If it is not valid, then we cannot pick it up. So you won't be able to pick it up right when it spawns, but shortly after you'll be able to. Now if we go back to our character interact, can drag off of our game logic. This should be valid at this point, otherwise we would not be able to interact with it. And we can call set player vitality. This will take an input of a player state as well as all of their values. So let's go ahead and we'll drag off of these and we'll promote them to a variable. So we'll call this health. Drag off of that and call it armor, just naming them all the same, and helmet. And this will be the amount to add per each value. And if you note they're set to -1 by default, that means that the value does not change for that statistic for the player. So what we will do here is we will get their current health and we will add health to it. And then off of the return of this, we're going to clamp this between 0 and 100. So we can't add a negative health value. We basically, well, actually we should set that to, yeah, it'll be fine, 0 and 100. We'll always be adding health, hopefully, as long as this isn't set to a negative value. But I guess you could do trap pickups where once you pick them up, they kill you instead of adding health if you wanted to. So we will do the same thing for armor. And the only thing that'll be a little bit different is for the helmet. What we will do is select off of the helmet. And if they have a helmet and that's true, we're not going to do anything. But if it's false, then what we will do is pass that helmet value in. So whether or not they would get one. And if it is true, we need to make sure we set it to -1 because we do not want to change this, or we could set it to 1, which just means that they have a helmet. So we can't technically use this to remove someone's helmet. But that's just about the entire setup for the pickup. Now if you were to create a child actor class, we could go ahead and expose these variables. And you'd be able to edit them on the child actor class, and you could have multiple health pickups, ones that are armor, ones that are health, ones that give you a helmet, and you could set their static meshes accordingly. So now that we've got our health pickup, let's go ahead and make one other pickup, and this will be our coins. This will be used for our game mode, so if you're not going to be making the game mode, you don't have to follow along with this, but this will be the start of us transitioning to game mode things and less into general subjects, I guess I should say. So what we're going to need for this one is a text renderer, and we will add this above the pickup. I'm also going to swap out the mesh to our coin mesh. Go back to the text render, and I'm going to set the horizontal alignment to center. I'm going to place it right above the coins, and then I will drop the text render, or drag and drop it on top of the static mesh to attach it. And then from there I'm going to go to the event graph, and we're going to need a variable here, and this will be the coins variable, and we will set this to an integer. This will also be rep notify for the replication condition, and what we have, once we set it to rep notify, we create this onRep function. So basically, anytime that this variable changes, the clients will call this onRep function. So we could use this to set the text for a text renderer. And we'll just pass the coin value right in. So you'll see above the coins, it'll look something along the lines of that. And you'll get to see the value that they contain in the world when you go to pick them up. Note, this isn't the best solution. You could potentially rotate the text so it's always facing towards the camera or something along those lines, but that tends to be a bit more intensive. So we're just going to take a simpler approach. These will be spinning, so at some point you'll have the text facing towards you. And we're also going to display the player's overall score to the scoreboard. So at any point in time, you'll just be able to open up the scoreboard and see how many coins you have in total. So let's go back to our coins. We need to create a function called setCoins. And we will drag out our coins variable, we will set it, and we will pass the coins amount in, and that'll create an input for our function. And then after that we are going to flush net dormancy. And then we'll click on the input and we will add an output variable. We'll remove the variable, that way we just get the return node. We'll pass it that way. And this is just to ensure that anytime you set the coins, we're setting it with the method that I described where you're flushing the net dormancy. And the reason we have to do that is because it's dormant all. This will basically allow us to not check if the variables have changed unless we tell it that the variables have changed. Now we need to do one other thing, and that is on event begin play, we will add a switch has authority. And on the remote side, we're going to basically need to do the same thing that we have here in onRep coins, but we want to do it after a delay. This will ensure that the player has time to replicate the coin value down to the client, and then they will set it client side. This is more or less for join in progress players. It'll prevent a mismatch potentially where they don't get the coin value replicated down to them, so they see it as zero coins in the level, but when they actually pick it up, because the value is stored server side and we're going to be adding their coins server side, it will still add them properly. They just won't know how many coins they picked up until they look at their scoreboard. So we're going to try to prevent that, and we will set this up. And then also what we want to do is add a delay for 2 seconds server side. And this will only allow the coins to be picked up after 2 seconds. Set can pick up coins variable, and we will set that to a Boolean. We'll set that to true here. And this isn't replicated because our can pick up is being called server side. If we were ever to want to call can pick up client side and we were going to add something like this to the function, we would need to replicate the variable. But once again, we're not going to be doing that, so we do not have to replicate this variable. So we'll go back into can pick up, and we will say can pick up coins if this is true. And what this allows us to do here is, in case of when a player dies, essentially how the game mode is going to work is everyone will start with 5 coins, right? As you kill each other, you'll get their coins from the player that you killed. If you're dead and you've killed a player, so say you throw a grenade, you die at that point, and then you kill a player, that player is going to drop their coins on the ground. So we need to prevent them from picking up their coins immediately when they drop them. So the way that we're going to do this is with the can pick up coins. It'll be false by default, so no one will be able to pick them up until 2 seconds have passed. That way we don't accidentally run into that issue. We're just about ready to set up the character interact function for our coins, but before we do this we need to set up quite a few things, including the game logic and the player info component. We need to make some changes because we're going to be keeping track of our coins in our player info component. So we're going to need some variables and functions for that. But first, let's change the way that we're adding the player info component, because right now it gets added when players walk over the speed boost, and I'd like to do it whenever players spawn in. So let's go to our game logic. We'll open that up. We'll also close out of the pickup and the health pickup because we no longer need those open. We'll open the full blueprint editor, and you can see we're starting out with a completely blank game logic, so I'm going to be making this all from scratch. So the first thing I'm going to do is I'm going to set up our respawn loop, and I'm going to use my own respawn loop so I could show you guys how to determine whether or not you should respawn someone. If you wanted to add, say, lives to their player info component, you could check how many lives they have prior to respawning them, and then you could determine whether or not you need to end the game based on how many lives they have left yada yada yada. So let's start setting that up. So the first thing we're going to do is off of begin play, we're going to add a switch has authority. Then we are going to delay for 1 second. So allow time for things to be initialized. And we are going to create 2 events. These will be custom events, and we'll call the first one start last round timer. And what we will do here is set timer by event. And we will drag off of our event pin on the timer. We will create a custom event, and we will call this set last round. And what we're going to use this for is to determine how much time should go by before it's the last round of the game and we'll end the match. So let's set this to, say, 60 seconds. We'll just do 60 times 60. And what we'll do here is we'll create a variable and we'll call this last round. And we'll set this to true. And basically what we'll do is we'll wait for the next round to end. When it ends, if this is true, we'll tell it to end the game. So we need to start that timer, start last round timer. Now we need to create another custom event. This will be start respawn timer. Same sort of deal, set timer by event. And with this one we're going to be checking every 1 second. And this will be looping. So we'll create a custom event and we will call this respawn dead players. And what we want to do is we want to get the round state, and we only want to run this, everything after this, if the round state is equal to started. That means that we're in play, we're not in transition between rounds spawning people. Now what we need to do here is get all the players that are in the game right now or connected to the game. So the way you could do that is get the game state and then get players array, get player array, and we are going to drag off of this and do a for each loop. This will iterate over each player in the array, and then we'll have access to their player state. We're probably going to be using this later down the line, the player array, so what I'm going to do is highlight that, right click, collapse to function. You have to click on the node for it to access this. It'll be called get players. We'll set it to a pure node. Once again by selecting the function pure. And we could access the players that way. Now that we have access to each individual player, we're going to get their player status. Get the Pavlov player status. If this is successful, we will add a branch. We'll drag off of the player status and we will break it. This will give us access to all of the variables within the struct. What we want to do is check if they're dead, and we want to check if their dead time is greater than or equal to however long you want them to be dead for before they respawn. So we'll set this to 5 seconds for now. If you wanted to make it a game mode where they're dead for only, say, 2 or 3 seconds, that would be fine, or you could do as long as, 10 to 60 seconds, depending on what it is, if it's objective based. And we're going to drag off of our AND node and add another branch. I should note here that you do not want to combine if it succeeded with all of this other information, because you'll be trying to access information that you technically do not have yet. So we'll drag off the controller. We'll say if the controller is valid, which it should be, but it's always good to double check. And we will get their spawn transform. And what this will do is find a spawn point on the map that's suitable for them, one of the Pavlov spawns on the map that's suitable for them based off their team ID and the other tick boxes. And we will drag off the controller once again and call spawn. We'll pass in the transform, and we are going to leave as ghost unticked. We do not want to spawn them as a ghost. And that'll take care of our respawn loop. Like I said, you can add your checks here if you wanted to create special conditions for in which people spawn. I'm going to cover a little bit of that. I'll kind of show you a basic example of how you could determine something along those lines. But let's change the way that we're adding the player info component. So what we need to do is override onPlayerKilled. And I'm going to create a function with the information that gets passed out of onPlayerKilled. So what I'm going to do is add a Reroute Node to make it easy for me. We'll highlight the reroute nodes, right click on the box on the orange border, collapse to function, and we'll call this player killed. Hook up the execution pin, and with the function selected, I'm going to rename the input pins. We'll call this player status and killer, the same as it is on player killed. Now let's go inside of our player killed function. And we're not going to quite set this up yet, but let's get this started. Essentially, in the player killed function, we're going to be dropping all of the players' coins, resetting their values, and things along those lines. But I want to get that created for now, and then we're going to create the onPlayerSpawn function. That was the one we needed. My mistake. Do the same deal, add a reroute node, and collapse it to a function. Player spawn. Rename it to player status for the input pin, and then we will go into our function, and this is the one I was looking for. Sorry about that. So we will break our Pavlov player status, and let me pull up my reference really quick. We'll promote our player state to a variable, call it LPlayerState, and we want to make sure that we promote this to a local variable. I know I did that quickly. We don't want to promote this to a variable, just a local variable. Local variables go out of scope once we leave this function. So you can see where they're not contained up here, they're contained down in our local variable section. And now what we want to do is get this player state and get component by class. And we're going to try and get our player info component. And if we can get this component, if it is valid, what that means is they've already been initialized, because we're only going to add this once for each player when they connect, or the first time they spawn, I should say. We're going to add it once per each player. And then if they already have this component, then we'll know that they've been initialized already at that point. So this will make sure that the entire time that they are in play, they're alive, they will have this component for us to interact with. So if it is not valid, what we're going to do is, with our player state, we will add component player info. We'll promote this to a local variable, LPlayerInfo. And we will set our player info, if it is valid, to this reference. Now we're also going to need our pawn, so we could pass that in when we initialize it. So we'll promote this to a local variable, lPawn. I'm going to try and prevent this function from getting too messy so you guys can keep up with it. Alright, and now that we have our player info component reference, one way or another, they either don't have it and we spawn it for them, or they have it and we get access to it. We will initialize the component, and we want to do this server side. And what we could do for this walk speed, so we never get into a situation where we forget to set it, we can go and change the default value for this. All I did was double click the function here, click on the input for it, and we'll drop down our walk speed and we'll set our default to 350, which is the correct walk speed. There, now we get it as a default. So we'll pass our pawn reference in. And we're also going to set the player's vitality here. So we'll get the player info ref, set player vitality, or set vitality, set player vitality, there we go. Oops, that was a player state ref, that's why it wasn't working. And we will give them 100 health, 100 armor, 1 for the helmet, which is on. It's 0 off, 1 on. And what we're also going to do is set player buying enabled, and we're going to make sure that we disable buying for this player because we're going to set up buy volumes on the map. So it'll disable within 0.5 seconds. And then we're going to spawn all players with default starting items. So they have default starting items and they'll be able to purchase items on the map. So we'll spawn everyone with a deagle for now. We'll spawn it in their dominant hand. That's all we need to do for that. And then let's add a return node to this function. Now we're not quite done. We need to add a couple things to the player info component, and then we're going to also initialize them here. So I'm going to show you guys how to add low gravity mode if you wanted to add that on a per player basis, where when they go off of a jump pad they have low gravity and they're flying for a very long time. And if we're actually going to do that, before I forget, we need to start our respawn timer on begin play in our game logic, and then let's also set fall damage to disabled. That way players don't die if they're in low grav mode, because you'll be flying for quite a long time depending on what you set the gravity to. Alright, so we'll go back to our player spawned, and then we'll double click init player info server because this is where we're going to be adding a couple things. So let's add a variable and we'll call this coins, and this will be an integer, and this will be replicated as well. So we will set this here and we'll pass it into the init, or the input for the function. And we're going to need a couple other things as well. We're going to pass in the team ID. We're going to make this so it works for TDM or DM. So we want to know what team they're on. It'll make it easy later on when we need to look up their team IDs, determine who's who and what coins belong to which team. Set that to -1 as a default. Our coins are 0 as a default, which is perfect. We'll pass in the team ID. And then we will also add a boolean, and this will be low grav. And this will be rep notify. And we will add a replication condition to this. This only needs to be replicated to the owner only. And we'll hook this up. We'll pass in low grav to our input. Sorry guys, this is boring to watch, I know. I'm just adding a bunch of variables and passing them. We also need to pass that to our player info client, and we will hook this up a little bit later. We'll pass if we have low grav enabled. Alright, so now let's go back to our init, and we will set everyone to spawn with 5 coins. We will get their team ID from the player status, and we will pass this in. And then we'll spawn everyone with low grav enabled. I'm just going to do that for this game mode. Why not? Might as well. If you wanted to, you can make a pickup that toggles low grav on and off, similar to what we did for the boost pad. You can make it to where once you walk over it, low grav's on. You could also make a scout knife setup out of this and just use low grav for your player info component, and you could set walk speed to be a little bit higher. Spawn them with knives and 50 cals. But there's a lot that you could do here. I just want to get the idea across that you could use this player info component for quite a few things to keep track of the player's information that they need to have. So now we have the player info component getting added to every player state once the player spawned in at least one time. And the reason that we're adding it to their player state versus their pawn is that their player state is persistent throughout the length of the match. They will not get a new player state. Rather than their pawn, they get a new pawn each time they die. So once they're dead, we could still access the information from their player state, which is a nice thing to do for persistence. For anyone that wanted to do some sort of persistent game mode, you could keep track of variables over the course of time through a component added to their player state. But we're actually going to use this instead for accessing their coin amount once they've died. And that way we can get their coins, and if their killer is dead at the time that they've died, then we'll drop all of their coins on the ground. We'll spawn the pickup coin instead. And so because we're doing that, we need to initialize it even if it's valid. Rather than spawning it each time and initializing it, we're going to go through and initialize it even if it's valid, just to make sure that it has the initial property set that we want, the correct walk speed, nothing left over from their last spawn. So now that we've gone through and done all of that, we need to make sure that we set our game mode property. So we'll override on custom game mode init, and we will set game mode properties, and we will drag off of our properties, and we will make game mode properties. And I'm going to show you how to do this in either team deathmatch or deathmatch. So we'll drag off of no teams, and we'll promote that to a variable called no teams. And prior to us setting the game mode properties, we're going to drag no teams, set it, and we are going to set this to a random bool. So it'll be random each time you start up a lobby, or each time the server rotates to this map. We're not going to change it during runtime. We're just going to allow it to stay with the one, either TDM or DM. And I just wanted to show you this to explain that you can actually have this as a game mode that works in either mode, and you could have it set up as a toggle, and then you could determine either based on the time of the day, which you can get UTC time, or you can use UTC now, and you can base that on the server's UTC time, so you're not using client-side time. There's also a way to get the time of day based on the server's location, I believe, but this would be a more proper way to do it, be universal. So that's just to show you that you could have teams either way. Now let's go through, and we want to set force no scoring on. We're going to be doing all of the scoring where it's based on how many coins the player has. That'll be represented in the scoreboard. We're going to turn off increment team score. We are going to set the inactivity threshold down to 30 seconds instead of 60, so things will despawn a little bit quicker. We're going to turn on dynamic spawns, and we are going to turn on spawn ghost on login. We also want to set our round duration to, let's say, 10 minutes, 60 times 10. You can adjust this as well, so I'll show you very quickly. If we wanted to make it longer for team-based modes, we'll add a select node. We'll hook up no teams to the index, and if there are no teams, we'll make it 7 minutes, and if there are teams, we will make it 10 minutes. Oops, 60 times 10, there we go, not 1. Now let's make sure that we are actually going through the round states, because right now what would happen is the game mode would start up and you would never spawn in because we would never actually get to round state started. So we will override on round end and on round begin. And on round begin we are going to delay for 1 second. We will set the round state to standby. We'll delay for another second, so I'm going to copy paste these two nodes over, and we will set the round state to started. And that'll take care of us transitioning into the round once the round has ended. Now once the round is ended, we need to make sure we go through and kill everyone. So first we'll delay for 4 seconds to allow time for people to, celebrate, kill each other, see who's won the round. And then from there we're going to end up needing to loop through all of the players, and we want to kill them. It's a very similar method to how we respawn the players. So what we'll do here is get players, do a for each loop. We'll get the Pavlov player status, branch if it succeeded. We will break the Pavlov player status. Let's make ourselves some room. What we want to do here is check for one that they are not dead. So we type in not, and then we get the top one, not Boolean. Branch. We also want to apply damage to their pawn, and we could check if this is valid as well. We'll add an AND node, so it has to pass through both of these in order to do this. The pawn has to be valid, the player is not dead, and then we will apply damage. And we will apply 1,000 damage here and kill him regardless of the case. And we're going to be adding or incrementing the player's score as they get coins added. So what we want to do when the player dies is remove their player score. So we will increase player score, or increment player score. And here we will get their score, and we will multiply it by -1. Get the inverse of their score and then add it to it. We will pass in the player state. Now once we're done with that, we need to transition to the next round. So we want to drag, you don't want to do anything off of the loop body, otherwise you'll do it however many times based on however many indexes are in the array. You want to do it off the completed node from the for each loop, so we'll drag off to delay. We'll delay this for another 2 seconds, and we will check to see if it is the last round. If it is the last round, this is how you return everyone back to the lobby. Or in the case of it being on a custom server, it would rotate it to the next map or restart the map if this is the only map in the rotation. So we will get the game mode, we will cast this to game mode, and then we will call end match. If this is false, what we're going to do is set the round state, and we're going to set the round state to starting. This will basically take care of our loop. If we wanted to create conditions for whether or not the round will begin, so if we want to check if there's greater than X number of players, something along those lines, we could do that here. And I would probably set that up in another timer. I covered that, I believe, in the second video, where I created a timer that had a condition where it would check if there were enough players. So you would just do something similar to that, where you would loop over, each player or check to see the length of it, and if there are 2 players in the array, then call down and transition into round state started. Just basically when it hits on round begin, you would set it to standby, you would start your timer. Once the timer check was complete and validated so you could start your round, you would clear the timer, and then you would start your round. Should mention really quickly that I actually got these values backwards in my haste. If no teams is true, then we want it to be the lower time value, the 7 minutes, and if it is false, then we want it to be the 10 minutes. But let's continue on. At this point, we are just about ready to start adding coins to our player info component. On top of that, we need to keep track of them within the game logic. So there's a couple functions that we'll need, and we're also going to keep a reference to the game logic in the player info component. It'll make it easier to go back and forth, so we don't have to get all actors of class. We actually have a very convenient way to pass the reference in. So if we go into our player spawn function within our game logic, and we add a node called this or self, we could pass that into init player info server. So we'll double click on that function to open it up, and we will add another input. This will be game logic coins. I'll just call it game logic, and we will promote this to a variable. And we're going to need that one later on to go back and forth between the game logic. Whenever we add coins, we're going to increment our player score. And we also need to check if we are at the amount that's needed in order for the win condition to be triggered. So let's go ahead and create those amounts really quickly. We'll go back to our game logic, and we're going to add 2 integers. The first one will be called coins to win. FFA, free for all, and we'll hit Control W with it selected, and that will duplicate it, and we'll call it coins to win TDM, Team Deathmatch. So if we hit compile, we'll be able to set the defaults for those, and for free for all, I'm going to make it 350 coins, and for TDM, I'm going to make it 500 coins. You could set these values as you'd like. You could also change these during runtime if you'd like. So between rounds, say on the second round, you could increment it by another 100 points, and you can make it more and more difficult to win as rounds go on up until that last hour. And we will also expose these by clicking on the little I next to it, or you could also select the variable and tick instance editable. Now let's create something very quickly while we're inside the game logic, and this function is going to be called, oops, it's a new graph, new function. We're going to call this get team score, and this will be used when no teams is false. And what we're going to do here is get players, where you're going to do a for each loop. And actually want to do a for each loop with break, because if we find a team with the correct score, sorry, it's hard to think and type at the same time, I know, right? If we find a team with the correct score, we need to break out of this loop and declare that team as a winner. So what we're going to do for each player is we are going to get their Pavlov player status. We are going to do a branch if it succeeds. We will break the player status. We want to get component by class from the player state. And we're going to be looking for our component player info. And what we're going to check here is this valid? Oops, we want the other one, the Boolean version. And we want to check if this is equal to a team ID, which we are going to pass into this function. So we're going to add an input, and that'll be an integer, and we will pass in a team ID. So basically a player will call this, and they will call it with their team ID, and it will check and add up their team ID's total to see if they've gone over the point which they would win. So that'll only happen when a player scores. So what we do here is we get team ID. That'll get the input rather than dragging it over. We can just type it in and get it. And then we will also get their score, or their team ID rather, and we will check if it's equal. And then what we want to do here is check that they are also not dead. We do not want to add any players that are dead. We do not want to add their score. So we'll add a branch off of that. So all of these conditions have to be met. The player info component has to be valid. The team ID has to be equal to the team ID that we are checking, and the player has to be alive. So after that, we will promote the player info component to a local variable, lPlayerInfo. And we're going to get the coins from it. And we will add this to another local variable. I'm just going to make it easy so I get the right variable type and name, I'll drag off of this, promote to local variable, lCoins. So we'll drag off of lCoins. And basically what we're doing is we are adding up all of the coins for the team. So we're just trying to keep track of it. So we're going to get their coins, we're going to add it to this value that we're keeping track of, and then we'll set that value. And then what we need to do here is get lCoins, see if it is greater than or equal to the coins to win TDM. If it is, oops. If this is true, we'll set a local variable, or we'll create a local variable, lWinner, Boolean, type Boolean. We will set lWinner to be true, and what we want to do is drag all the way from the end to the break on our for each loop. And I'm going to do the same thing as before, where I double click on the execution pin, or on the execution wire, to add a reroute node, and this will clean it up to make it more clear as to what's going on. So lWinner will start as false by default, and if we exit out of this function once it's completed and lWinner is still false, then we'll know that they didn't win. They haven't reached that point yet. But if it is not false, then we will know that they have won. So we want to return that. So we're going to add it. We're going to click the function, and we are going to add an output Boolean, and that will be winner, or yeah, we'll just call it winner. We'll pass that there, and then we also want to output the amount of coins that we got for that team. So we could use this to set any team scores that we need to. That way we don't have to do the calculation twice. Since we're already going through and doing this, we might as well take advantage of having that coin value. So we'll pass those two out of the return node. Next, we're going to create a function that uses this team score and sets it to the team score in the scoreboard. So we'll create a new function called setTeamScore. And we're going to use the function that we just created, getTeamScore, would be the first thing that we do. We'll pass our team ID into the input for this function. We'll set the winner to a local value, lWinner, or promote it to a local value, I should have said. We'll promote coins to a local value, lCoins. Then we will call a Pavlov API function called getTeamScore. And notice we have two functions with the same name, so we should take care of that really quick. We'll rename this to getTeamCoins. We will get our team ID, that'll get the input for this function. We'll pass that in. And we will take our lCoins value and we will subtract our current score from it. This will give us the difference of the score, the amount that we need to add to it. So then we can call another API function, increment team score. We will pass in the team ID, and we will pass in this value. And now we need a return node off of this function, and we will return if this team ID is the winner. Need one more function, then we can go back to player info and we could finish up in there. And then we could finally get back around to our coins and implement that. So let's create this function, and this is going to be check if winner. And we are going to pass in the player info component, because this is going to be called from the player info component. And we want to make sure that the round state is set to started, otherwise we do not need to do this. And we also want to make sure that the reference that we're getting passed in is valid. So player info component, convert to get valid. And if it is valid, we need to now check if we are using teams or not. So if no teams are true, we just need to check against the free-for-all value. If teams are true, then we need to check if the team's value is greater than the coins to win. So if it is no teams, let's take care of that because it's the easier one. We will get the player info, get player info component, get coins. Let's check to see if this is greater than or equal to coins to win free for all. Branch. Just thinking ahead here because I'm going to do something later down the line where I'll create a scoreboard, and if it's a free-for-all match I want to show the player's name, and if it's a team-based match I want to show which team won. So let's actually do something real quick. We're going to get the owner of the player info component, and this should be the player state because we added it to the player state. If you see, it follows the outer chain that owns the component, so it would be the player state, which we will cast it to. And we want to get the player name. Oops, that's a player start. Wow. There we go, that's the correct one. Player state. Get player name, and we're going to promote this to a local variable, player name. You'll see why later down the line that we're getting this and storing this. So if this cast failed, we'll add a reroute node. We'll still allow them to win, I guess, even if we can't get their player name. It'll just go through with a default name of none. I selected the local variable and I just set that as the default. So now if this is true and they have won, we're going to create a new event in our event graph. Custom event, declare winner. And we are going to pass a integer, and this will be the team ID. This, if it's equal to -1, we're going to treat this as deathmatch. So if this is equal to -1, but we're also going to have whether or not we have teams, so we'll just use this bool because that'll be more reliable in this case. But we also want to pass the string for the winner. That way we just have one case that we need to pass for who won, or one event that we need to call for when someone wins. We will add a do once here because we only want to do this once until the round's reset. Alright, so we've got that going for now. We'll finish this up later down the line for declare winner. Well, let's go finish up check if winner. So we could call declare winner. We will say team ID -1, which technically doesn't matter in this case, and then we need to get our local variable, which is the player name, and we'll pass that. That's the one that we actually care about in this instance. So if no teams is false, right? So if we have teams, we need to do something a little bit different. We need to get the team ID from the player component for one. Get their team ID, and then we need to set the team score for that team, which will tell us if they are a winner or not. And if they are a winner, let's actually go ahead and promote this to a local variable, L team ID. Oops. And we will call team 1, or declare winner rather. We'll pass in our team ID. We don't care about the player that won in this case because we're going to display the team's name, red or blue team. In this case, we'll display this such and such player has won the game or won the round. And this will take care of our check if winner function, or check if player's winner, check if team's winner, and know exactly what to call it, so we get a generic version. Now let's go into our player info component, and we're getting close to wrapping this up here. We're in the home stretch. Let's add a new function, and we'll call this set player score. And since we've set the team score, that'll be good to go on the scoreboard, but we need to actually increment the player score so you could judge, how well someone's doing based on their score. And you could also check very quickly how many coins you have. And in order to do that, we are going to get our owner. We'll make sure that this is valid. It should always be valid in this case, otherwise the component wouldn't be valid, but it never hurts to double check. Cast it to player state. And from here we need to get the Pavlov player status. Oops. And we will do a branch off of that. We will break the player status. We will get their score and we will promote it to a local variable. Now we'll take their coins, we'll subtract it from their score, and that'll get the amount that we need to add to their score in order to get it to the proper value. So we will get our game logic, convert this to get valid. Should always be valid, but once again doesn't hurt to double check, and we will increment if I could type right now, increment player score, and we will pass in our player state from the player status, and we will pass in the value that we get from our subtraction. Now let's create a return node for this by adding an output. We'll remove the variable. We don't need the variable. We will hook up all of our execution pins to the return node. I'm just using reroute nodes by double clicking to make this look cleaner. Okay, now we can get to the major function that we need to use, which is add coins. Up until this point we've had no way to add the coins, which will finally wrap up this pickup coins. So let's go into here, and first thing we need to do is make sure our game logic is valid. And we will get our round state, and we want to make sure that we are in the round state started. We'll add a branch. And then we need to get our coins, and we will create a set node. Going to drag from the input of the set node all the way to add coins, and that will just create our input with the proper variable name. Now from there, what we're going to do is drag off of our coins value. Let's clamp this. Oh, we'll actually clamp this prior to going in, and we will take our coins variable, coins plus coins, as I'm sure you imagined. We'll call this coins2 add, so there's never any confusion between the two variables locally. Clamp this between 0 and 500,000. I don't know why we would ever go over that value. And then from there we need to call our set player score, which will set our individual player score. Then we need to get our game logic, and we need to check if winner. And we will pass this into winner or self, which is a reference to this blueprint. Now we're going to add an output to this function, and we will call this current coins, which will be of type integer. And we will pass in our coins value. You need to also make sure that this is hooked up in all cases, so we'll add a reroute node here, and we will add this to our return node. Do the same thing over here, and there we go. We finally have our add coins function finished, which means we could go back to our pickup coins, and we basically just need to check if the character is valid, which it should be at this point, but as you can see, we've gotten into the habit of checking if everything is valid. It'll prevent any odd crashes that you may run into, so it's a good thing to get in the habit of. Now we will get the player state, convert this to valid get. We will get the component by class. Oops. Not components, you want to do the singular version, get component, component player info, say is valid, and if this is valid, then we want to add coins, as you may have guessed. And our coins to add is our coins variable. And I'm sorry for all the Discord notifications. I'll make sure to turn them off after this clip. So we want to make sure it's successful after we do that. In all other cases, it needs to return not successful, because if something was invalid at this point in time, we need to allow someone else to go through and try and pick up the coins. So you can see here, if any of these are not valid, we will return that it is not successful. And once we have added the coins, we will return that it is successful. And in case you've forgotten at this point, if we go back to our BP pickup class, if it's successful, no one else can pick it up because our do once will never get reset, and then it'll destroy the actor. Alright, so that wraps up our coin pickup. Now we need to make sure that we're transferring coins between players when one player kills another. If not, then we're going to actually spawn this coin pickup into the level, and we are going to initialize it with their proper coin value, however many coins the player has. Let's add low grav real quickly, and then we will go ahead and we'll wrap this up. So let's go into our player info component, and we'll go into the onRep low grav function. First thing we'll do is control drag our pawn out, right click it, convert to validated get, and we will need to get the movement component. We will cast it to character movement component, and we want to get the gravity scale, or set the gravity scale. Now we're going to drag off of the gravity scale input, and we are going to create a select node. and you'll notice it has a wildcard index. What we're going to do is bring LowGrav into the event graph, and if we plug that into index, it'll convert it over for us. Now if it's true, we want to set this to 0.35. You could play around with this value, or you could promote it to a variable if you'd like, the low grav amount or the low grav scale. But 0.35 seems to work pretty well. Like I said, you could turn it up maybe a touch, but I wouldn't go much lower than this. Otherwise, you're going to have people sort of floating off in the distance anytime they go over jump pads. So now we're going to copy this portion of it, the set gravity scale. And if you remember, we have our init player info client. We also want to make sure that it initializes the gravity scale for the client when the player spawns in. We will pass that there rather than using the low grav param. This will just make sure everything's up to date when we initialize between players, between pawns, since the variable will technically not have changed if they had low grav enabled and it is still enabled when they get reinitialized. It won't force them to turn on low gravity, so we want to make sure that we force that to happen when they go through initialization. Alright, now that we've got that taken care of, we can go back to our game logic. And in our game logic, we had that declare winner event. What we need to do after this is set the round state. We're going to set that to round state ended. That'll trigger it to go through the loop where it kills everyone. And then we will add a delay here. And we'll set that delay to 5 seconds. After 5 seconds, we're going to reset the do once. Now we need to set up the player killed function. This is going to be one of the more complex functions that we've gone through so far, so kind of prepare yourself here. Basically what we need to do is, if the killer is valid, we need to give them the killed player's coins. And if the killer is not valid, we need to spawn the coins at the player's last location. Seems simple enough, but you'll see it's going to end up being quite a few nodes. So we only want to do this if our round state is equal to started. So if the round state is equal to started, then we will get the player status. Note that's the same thing as dragging off, it's just cleaner because you get it in a variable. We could split the struct pin. Also same thing as if I were to recombine it, calling break. You can use it this way as well. And we need to promote the player state to a variable. And this will be called L killed player. We'll call it killed player state to be verbose so we don't think it's a pawn. Now what we need to do from here is get component by class, and we need to get the component player info. And we need to check if this is valid. If this is valid, then we need to get the coins from it. L coins. And we will also promote the player info to a variable. And we need to set up one more function inside the player info component to reset their coins to 0 value in case somehow they go through the adding process where it's adding up team scores or something along those lines. We can make sure that we reset that. So we'll go to the player info component and we will create a function called reset coins. we will take our coins and we will set them to whatever we want the reset value to be. And then we need to call set player score. That way it goes through and sets our score. We'll add a return node for this. We don't need a parameter off the return node. Now let's go back to our game logic and let's call that reset coins. It's important to do this after you get your coins and set them to a variable, because we need to know how many coins they had when they died, and then we need to spawn that many coins, or we need to give that many coins to another player, and then you need to reset their coins after we've stored that. So moving along, we need to check if the killer is valid, so we can get killer. Once again, that's the input from this function. Could convert it, but we'll just do is valid for this one. If it is valid, we want to check if the player killed themselves, because we do not want to give them coins if they've killed themselves. So we'll drag out the killed player status, and we will see if that's equal to the killer with a branch. And then we need to KitKat stop. KitKat scratching my chair. Now if this is false, if this is not equal, we need to get the killer's player status. Like I said, this is going to be quite a large function, so bear with me here. And I'm going to start getting all of our returns where we're not valid or where we're failing out for whatever reason, and I'm going to start putting those in order. So I'm going to create an output node, and I just want to keep this orderly so we can keep track of what's going where, because this is going to get rather large in a minute. So these two will get a reroute node. Now we'll hook these up. In these two cases where the killer is equal to the killed player, or the killer is not valid, we need to spawn the coins in the world. So we need to designate those as a different condition. And then also, if this fails, we need to go down that route as well. Alright. And then we will break the player status. We are going to get this player's player info component. Get component by class, player info. And we want to say if this is valid, and we want the function version, not the macro, the top one, and this player is not dead. We don't want to award them if they're dead. So we'll go with those two. And that's an AND node, so it has to meet both of those conditions. We have to be able to get their player info component to add the coins to. They also have to not be dead so that they can receive the coins. Now we'll promote this to a local variable, L component player, or we'll just call it L player killer player info. Trying to be verbose so you guys won't get confused later down the line looking at this. And then we want to call add coins, and the coins to add will be our coins value. And we will add our return node here, because if we have gone through all of this, we have successfully completed this function. If we cannot meet these conditions, like I described earlier, then we also need to try and spawn those coins into the world. Alright, so now we will get this player status, the killed player status. And we will say if the pawn is valid, we're going to try and use its location to determine where the coin should spawn. If the pawn is not valid, we really don't know where to spawn their coins, so we are just going to skip this altogether, and the coins will basically disappear. You can log this if you are running your own community server. You can call log performance snapshot, and you could pass in something like append this Steam ID, pawn not valid, can't spawn coins at their location. And so now if you're running on a community server and you check your logs, you'll know if this condition's been met, but it shouldn't happen very often overall. Every time I've tested this, I've had players' coins spawning where they should be, so we'll move on from here, and what we need to do is determine where we're going to spawn these coins, because we have their location, right, and we could just spawn them at the pawn's location. The coins are already floating, but we want to try and place them as close to the ground as possible, or whatever they're near. So what we're going to do is we're going to call a line trace by channel. And this will create a line trace that will check the visibility channel, and we want to ignore an actor, make array, and we want to ignore the pawn. And what we're going to do here is we're going to get this actor's location, get the pawn's location. We'll plug that into our start. And then for our end, we're going to do this location minus, and we could call 500 units, so it could potentially try and place it 500 units below, but it'll only go up until 500 units. It's the first blocking hit. And if we wanted to, we could potentially go above wherever the player is located, but we shouldn't really need to do that because they should be above the floor or whatever they are on. So we should be good in that regard. So now we will add a branch off of the return value. So if we get a blocking hit, we will break it. And what we need is the location. And we are going to spawn an actor from class, and this will be our pickup coins. So what we need to fill out is the spawn transform, so let's promote that to a local variable, L spawn transform. And let's give it some defaults. It has 111 set for the scale, which is perfect. We want to try to adjust location, but we want to always spawn these coins. And now we're going to set our transform. So if this was a blocking hit, we will take this location and we will pass it into the transform. It'll convert it from F location to an F transform. We will do the same thing on false, but we won't pass the location. We're going to pass the actor's location. So I'll pass that in, and this is where things get sort of messy. I'm going to clean it up to the best of my ability right here. Didn't like that. Alright, there we go. So we check if the pawn's valid. If the pawn is valid, then we get their location, because they should have a valid location. And we will try and get the location below the pawn. So we will try and line trace up to 500 units below the pawn, get our blocking hit, and we will spawn the coins at that blocking hit's location. If we do not get a blocking hit, then we will just spawn the coins at the pawn's location, because it's better than not spawning them at all. So we'll pass this into our spawn pickup coins, and we need to do one thing, which we do not have yet. We need to initialize the coins value. We need to set how many coins we have for the pickups. So we'll go back to our pickup coins actor, and let's create a function called init. Oh, we have a function actually, set coins. We'll use that. Forgot I was looking for a different function name. So we go back to our game logic, we call set coins. We get our local coins value, and we will set that. And then let's add our return node. We could just go find one and copy and paste it over here. So there we go. There's our function to determine if someone should receive coins when they die, or if we should spawn coins in the world, and we try to do it safely with validation, so we're not just pulling null pointers and trying to access null information, because then you'd end up with coins spawning at 0, 0, 0. Alright, from here we could pretty much move on to some bonus information. I could show you some things really quickly. If we wanted to set up, say, events that get fired, or rather sounds that fire every time we pick up coins, we could create a custom event, and we'll do that in our player info component on the event graph, and that will be called play sound underscore multi. And what we will do here is go to where it says replicates, and we will drop that down, and we will create a multicast event. And we do not want to tick reliable. It's not a good idea to make multicast events reliable because they're sort of unreliable in their nature. So we'll go down to inputs, we will go to sounds, or rather the type for our variable, and we will put in sound base. We will call this sound. And what we will do here is say is valid. If the sound is valid, then we will also check actually if our pawn is valid. So let's change this. Is valid function, not the macro. We'll do the same thing for this. If both of these are valid, then we will play sound at location. And we will pass in the sound variable, and our location will be get actor location. Now if you drop down for the sounds here, you could see that you could input attenuation as well as concurrency. The attenuation is more the important part. That'll determine how far the sound travels and sort of the fall off rate of the sound itself over that distance. So I would do some researching on this, but we do have plans, or I have plans with Adriano eventually to do a video that will cover sounds. So hopefully you guys will be looking forward to that. But for now, we're not going to pass in any attenuation. You can do a quick Google search on how to set up attenuation, and then you would just plug it in here. But what we are going to do is go to our pickup coins, and if we have added coins, we are going to call, drag off of the player info, play sound multi. And I have a couple sounds that we've provided for you guys. You can hear the randomized. Later on, we'll show a setup where you can convert these into queues by right-clicking Create Queue. And then you can go into your queue and you could set these up to randomize. And you can basically copy-paste these nodes in, hook it up to your output, and then you would just select the next one. So you have a couple different sound cues that you could play. Note, we do not want to set this to loop. We just want this to play, and then it'll get destroyed when it's done playing. That's the key. So we will go back over to our pickup coins. We will plug in our sound cue that we just made, that is the two randomized ones. Hit compile and save. And now it'll play a sound whenever someone picks up a coin. As long as they have a valid pawn, that is. And it's a valid sound. Alright, so I forgot one thing that we're going to go ahead and add in. If we go over to our component player info, we go to reset coins. What we're going to do here is get our game logic, convert it to validated get, and we want to call We want to first see if get no teams is false if we are in TDM. And if that is the case, then we want to call set team score. And we'll pass in our team ID. And that's just to make sure that we have it updated in both the player score as well as the team score will get updated. We don't need to check if they're winning here because we should just be removing coins in this instance. They will never have technically more coins. Whenever they do, they'll go through the same check, but it could potentially declare the winner. So that should take care of all cases and also make sure that the information that's being displayed is up to date. Now from here we have basically one last thing to do to wrap this up. It'll technically work as is. Just right now when the match ends, there's no clear designation as to who's the winner. There's also no sounds that play to let players know that their winner has been declared. What we could do if we wanted to make it somewhat simple is we could just end the game mode instead right here. And if we did that on in a server, it would basically show the winning screen and then it would go back to the lobby after that. But let's keep this as a round-based game mode like we have it right now, and we will go and we'll create a new blueprint. And this will be a little advanced because I'm going to show you guys some stuff on widgets, which I haven't quite shown yet. So bear with me on this. We'll create a folder called widgets under our UGC. And we will create a new blueprint class, and we will call this BP_winner. We'll open it up. This needs to replicate. We could set the net dormancy to be dormant all. We need to go to components, and we need to add a widget. You won't be able to see it in the viewport until we go ahead and create that widget, which I will do shortly, but let's finish the setup for it. We can remove everything besides begin play on the event graph. So what we could do is call a function isDedicatedServer. We could do a branch. So if this is going through event begin play on a dedicated server, we want to go ahead and destroy this widget component. We just want this widget to be client side. So we'll drag out from the widget. I just did a control drag from the widget, right clicked it, converted to get valid, and I'm going to call destroy component. And then we need to do a couple other things here. Let's create one. First off, let's create a custom event, and this will be a multicast. Or actually, we could do this a different way. We'll set up replicated variables, and when that triggers, we'll set up sound to play. That's essentially what I was about to do. So let's go and create our widget first and foremost. We'll go back to our content browser. We will go to our widgets folder, right-click user interface category, then widget blueprint. We will call this WBP for widget blueprint _ winner. And let's pop that open. I'm not going to go ahead with the full art setup for this. You guys can provide your own art, but I'll show you guys how to get started with some widgets and how to replicate information down to clients and display it on widgets. So in the top right corner in our designer tab, we have something that says fill screen. We'll drop that down and we'll change that to custom, meaning we're going to provide a custom size. We'll set this to 1024 by 512. We'll go ahead and we'll add a border as the first thing. In the left-hand palette, we'll find the border. We'll drag it on top of our canvas panel. We'll select the border, go up to our top right anchors, and we will select the full screen anchor, the bottom right anchor. Now we'll go down to our offsets, and offset bottom right set to 0, offset bottom set to 0. Then we will go down to our brush color, and this is where we could set our color for the background. You guys can set this to whatever you'd like. We'll set it to this color for now. You could also provide a image if you'd like for your background. So that would be quite a bit easier. You just plop your image in, and as long as you set it to 1024 by 512, when you create the image, it'll line up perfectly. So now we need to add a vertical box, and we will add that on top of our border. And the first thing that we'll add to our vertical box is text. So we'll drop text on top of our vertical box, and we will type in the text field coins to win. And we'll set this, if we go up to our padding at the top, this is the amount of padding we want to provide around the text. For our left padding we could do 15, and for our top padding we could do 15 as well. And then we need to drop down our font, and let's set that to be 48, should be fine. And now we're going to need to add the winner text in the center. So this will just show the coins to win, and it will show an amount, and this will be displayed throughout the duration of the match. And then we want to have text that will be hidden, but when a player wins or a team wins, it'll pop up and it'll display winner and then either such and such's name or the team, red team or blue team. So to do that, we'll create a size box. We'll add that on our vertical box, which will place it underneath the text. And then we will add a text box to that as well. And what we want to do is click our size box. We want to set our width override to be, we'll do 800. And we will set the horizontal alignment to be center. And then what we want to do is add a top padding of say 100, and we want to add a height override of 250 should be fine. And we'll click on our text on the left, we'll set the text size, and let's see, we could set that to 48. And we will justify it to the center. We'll type in winner. So this text will get formatted. We'll do that later on. I'm just typing in placeholder text in the meantime. But we also need to set the visibility on this text because we only want it to be displayed when someone wins. So we'll come down to visibility and we will set this to collapsed. Now just to show you what we're working with so far, we'll go back to our BP winner. We'll go to our widget, we'll select it, and then we go to our widget class. If we drop that down, we only have one there, BP or widget blueprint winner. And we will set the draw size to 1024 by 512, which is what we specified in the blueprint. And if we look in the viewport, we can see we have this huge widget. What we could do here is hit R to scale, and we could scale this widget down to be a little bit smaller than what it is, and we'll go ahead and move it up. So when we drag them into the world, it's not in the floor. Alright, so if we go ahead and drag the BP widget out, you can see it's facing the wrong direction, but if we rotate it, oh, there we go, we've got our information. And because we've set this text to collapsed, you won't see it as collapsed right now, but once we hit play, you can see there's no text there. So we will need to toggle that to be visible. Now what we need to do, once we're back into our widget blueprint, we'll select our text, and we can see at the top we have a name up here, and it's just set to text block. We'll call this winner text, and then on the right of it we'll click is variable. This will allow us to edit it during runtime. Now if we go back to our other text, the coins to win, we'll call this coins to win text, and we will also set it to be a variable. So now what we could do here, if we go to our graph, our event graph for this, we can delete all the nodes, and we will create a new custom event, and we'll call this first one set coins to win. And what we will do here is we will take an input of a integer, coins to win, and we will get our our coins to win text. We'll drag that out and we will set text. And we'll drag off of the in text and we will format the text. This might be a little much for you guys to understand, but basically you could format your text this way and input parameters into it. If you don't quite understand what I'm doing, you could do append instead, and you could plug in your coins to win here, type coins to win. But we're going to do it this way just so I could show you. So we'll type coins to win. This is all the text that'll show up like normal. Then we'll do squiggly brackets, and we'll put in C1 inside of the brackets. When we hit enter, it's going to create that C1 parameter, and we'll plug it into coins to win. Basically, this is a wildcard variable, and you could input something into it, and it will show up here in your text string. So we will compile and save that. And we're also, let's go ahead and do one other thing. Let's add a toggle for if it is teams, because we could actually format this text based on if it's teams or not, or if there are teams or not. So we'll say no teams. If there are no teams, we will select, and I need to drag off of this and call make literal text just so it will know the type that I'm dealing with. And what we'll do here is we will change this text to say first, we're going to do squiggly brackets, first S for string or text, either, whatever. First S to collect C1 coins to win. Or we'll actually change this. First team to collect X coins wins. So if this is, let me hook this up. If this is true, there is no teams. We will say first player to collect X coins wins. And if this is false and there are teams, we'll say first team to collect X coins wins. Now we need to do something else really quickly. We will create another custom event, and we will call this set winner info text. And this is where we will pass in the team or player that is won. We will create a text input, and this will be winner, and then we will create another input, and this will be show, and this will tell us whether or not we need to hide or display the text. So what we could do here is drag our winner text in, and we will set text, and we will create another format text node. We'll type in winner, shift enter to add another line, and I will add S here with the squiggly brackets. If I could only talk right now. This tutorial is taking quite a while. Sorry guys, it's sort of draining me as we're going on. But we will also copy paste the winner text over, and we will set visibility. And this is where we will determine whether or not we need to show it. So we will drag off of our visibility enum, which is what this invisibility is, and we will call select. We will pass in our show variable. And if it is false, we want it to be collapsed. If it is true, we want to show it. So basically, whenever we have a player that wins, client side, we will pass down the winner's name or the winning team. Then we will show it here, and we will format the text, show it, and when we initially load into the game, we'll probably query this information or pass it down, and we will set it this way. So let's go ahead and move over to our BP winner. We're more or less going to be working within the winner at this point, and our game logic can go ahead and close our player information for now and our pickup coins. Okay, let's finish up the replication for the winner widget. So we'll open that back up. We need to add 3 variables. The first one is going to be the winner text, and this will be the text that we pass down that gets displayed either the player name or the team, and we're going to set this to rep notify, and that'll go ahead and create that function for us to use. Now we need another variable. This will be of type int, and this will be coins to win, and this will be replicated. We need one more variable of type bool, and this will be no team, and this will also be replicated. Now we need a function to initialize the round information, the coins to win and the team, and then we'll need another function that we'll use to set the winner. So let's go ahead and create the first one, init round info, and we will set coins to win and no team. We'll pass these both into the input for the function. And then since this actor is set to dormant all, we were going to need to flush net dormancy. And also I should add, I went ahead and ticked this in between cuts, but make sure you have always relevant checked as well, because we want this to send out information to all clients, no matter the condition of how far away they are. So we need to create a function or an event now that's a multicast event. So we'll create a custom event, and this will be set init info, and we will call it multicast. In the replicates dropdown, we'll set it to multicast. Now what we need to do here is we need to make sure that the widget is valid first and foremost before we go ahead and try and call anything on it, because we do destroy the widget on the server. So we'll get user widget object off of widget, and then we will cast that to our widget blueprint winner. And then we need to call the event that we made set coins to win. And we're going to pass these in to our event. And you'll notice that it'll make the inputs for us with the correct name and the correct type when we do it that way. Just makes it easier rather than clicking on it and typing them all out. So now we need to make sure that we call that set init info. We'll pass in the variables. And we need to create that other function that I had talked about to set the winner. So we'll call that set winner. As you can imagine, we will just do the same thing. And the reason I wrap these in functions when I'm just setting a couple variables is because I'm going to flush the net dormancy. So if you're going to do quite a few things, you might as well wrap it all within a function so you don't have 5 nodes on your graph. It's just one function whenever you go to set something. It's important to remember when you have the net dormancy set. Alright, so now that we've gotten that taken care of, we can take care of our onRep function, which this will do the lifting in terms of deciding when to display the information. If it's not set to anything, then we can determine that we probably shouldn't show the winner info. But if it's set to something other than none, then we probably should show the winner info. So that's basically what we're going to do. We also want to make sure that our widget is valid in this case. We'll get the user widget object. We will cast it to widget blueprint winner. And we will set winner info text. We will get our winner variable, we will pass that in. And what we could do here is if winner is not equal to, and let's actually do case insensitive, and then we will make literal text. And we will say if it is not equal to none, then we want to show it. And then on top of that, if it is not equal to none, we want to play a sound because that means the round is over. So we will play sound 2D, which means it is not in the world. It's just a 2D sound that you would hear. And this will be the when confirm sound. Play it for you guys real quick. Thanks to our audio guy, making great sounds. Alright, and that pretty much takes care of all of our replication except for one condition, and that would be join in progress. And during join in progress, we want to make sure that they get the valid information. It'll be stored on the server already, but chances are they may not have set it properly for whatever reason. Either the widget won't be valid at the time when they joined, or it won't get replicated down to them, or the rep notify won't fire to tell them to run the event rather. And in this case, we just do this once, right? And then we forget about it. So if they miss this event, then they're kind of screwed at that point. But this will sort of be our saving grace. We will add a delay if it is not the dedicated server, so this is expected to be client-side. Add a delay for 2.5 seconds, which will allow enough time for the variables to replicate down. It'll also allow enough time for the widget to initialize properly. We'll get our widget. We will get the user widget object, as you guys have seen, casted to widget blueprint. And we will set coins to win. And these variables are replicated, so they'll be valid client-side. And then we also want to, well actually we'll do this on a branch because we only want to set this if the text is not equal to make literal text none. It'll be hidden by default to begin with, so we only have to worry about showing it if that's the case. And then we will set winner info text. We will pass in our winner and we will set show. And there we go. That's our setup as far as this widget goes. We could drag them out into the world and they will update. You could technically even attach them to the player, the ones that are dragged out into the world client side if you wanted to, and keep them hidden, and then when the round ends you could display them. You could add it to the watch. This setup isn't technically universal, but the way that the variables are replicated and the way that I'm getting them here is fairly universal. You could also bind them within the widget itself to variables. So there's quite a few ways to go about this, but I just wanted to show you something quick that would work where I'm not going to be spending an hour and a half on just widget replication. So now we need to set this up in the game logic. There's, I believe, just two places we really need to set this up. So when we declare the winner, we definitely need to set that up. So what we'll do here is get all actors of class BP winner for each loop, so we iterate over each individual one. And what was the event called? Set winner. And this is where we could sort of build the string here if we'd like, or we could potentially build the string and set winner if we really wanted to, but we'll build it here. It'll make it a little bit easier. And let's collapse this to a function to get this a little bit neater. We'll pass in these two variables that we'll need, the player that is one and the team ID. We'll highlight it all, right click, collapse to function, and set winner info. We'll add this in right after we end our round. And let's give these inputs names. So this will be team ID And this will be player winner. Okay, so we need our no teams variable, and we are going to add a select based on that. We'll hook that up to winner so it gets the type, which is text. We'll remove these reroute nodes, and I will do get team ID. I have to compile. So if you ever run into an issue, I wish this would have happened earlier, where you can't get access to this variable when you right click and type it in, you need to compile first. Get team ID, get player winner. Okay, so if there are no teams, and that is false, meaning that we have teams, we will select this and we will type in blue team for team 0, red team for team 1. And then if it is, if no teams is true, if it's a free-for-all, then we'll pass in the player winner, which will display their name. And that is basically all that we need for that function. So it'll take care of that. And then we need to go up to where we are setting our round states. And when we initially set our round state, let's go ahead and set that information. That way, if for whatever reason they miss the update, the next round they should most definitely have that update. It's one of those very rare cases where it would happen, but it would be an instance where they're potentially lagging quite a bit and they would miss the update. So this would ensure that eventually they would get the update. So what we want to do after we set our round state to standby is do a post-round cleanup. This will remove all actors from the level, guns and bodies and things of that nature. And then we are going to iterate through all of our scoreboards, and then we want to set the winner to be none because we're starting a new round, so we want it to be hidden. And then we also want to init the round information again, as we discussed. So let's create a function for that. And then we'll call this, oops, that's a new graph. I did not mean to do that. A new function, we'll call this init scoreboards. We will get all actors of class. Blueprint winner. Do a for each loop. And we will set the winner. We'll set this to none. We will set the init round info. And we can do a select node off of no teams, and this will determine which score we're going to select, which is the winning score, because we have the free-for-all one and the team deathmatch score. So if no teams is false, we want to select TDM. If no teams is true, we want to select free-for-all. And we'll pass no teams in as well. And then for this, I want to click the input for the function, click output, remove the variable, and then hook this up to the completed node on the for each loop. I just like to make sure that I have returns when I'm adding functions like this. Oops. Init scoreboard. That way we wait for the function to finish before continuing. Okay, now that we've got that all taken care of, let's see. We need to change one thing that we had forgotten about for quite some time, and that's with our speed boost. This still adds a component which would get us into a situation where we would have two player info components, which we don't necessarily want. Granted, we always try and access it in the right place, so that wouldn't necessarily be an issue. We just would like to avoid that if at all possible. So let's go ahead and remove this. And what we're going to do here is off of character, we need to get the player state. We need to make sure the player state is valid. And if the player state is valid, we want to get the component by class player info component from the player state. And if that's not valid, we are just not going to worry about it because they didn't initialize properly, so something had to have gone wrong. We shouldn't try and add it really from the speed boost. We should just wait for them to die and get it added again. But I haven't really come across a situation with the setup on player spawned where they're not getting the component added. It's always been valid in the cases that I've ever used it. We've got a couple things left to cover. We're going to go over some spawners now. So you could spawn in your health pickups in the world, and you could spawn in your coin pickups in the world if you really wanted to. A reset interface, so in between rounds we want to destroy all of the coins that are in the world. We want to reset all of the spawners. We also need to set up on-player left server, I believe it is. Yeah, on-player left server. So I'll add that event so we have it for later. And I'll go over the optional player lives for respawn mechanic as well. So let's get started on the spawner. We'll go to our pickups folder. We will create a new folder and we will call that spawner or spawners. We'll open that up. We'll create a new blueprint class and it'll inherit from actor. Name this BP pickup spawner. And we'll open that one up. And we will set this to replicates. We will set it to dorm at all. Compile and save that. And for this, it's going to be fairly straightforward spawner. We're not going to get overly complicated with it, but we will add some randomization to it if you'd like to set it. So off of begin play, we'll add a switch has authority. We will add a delay for 2 seconds. Just allows us some time. And what we want to do here is start our spawner, so we need a custom event for that. Custom event start spawn timer, and this will be run on server and it will be reliable. And what we want to do here is set timer by event, and for the event we'll create that really quickly. Custom event spawn item. We don't need to worry about replicating this really, or setting this to replicated. We could, if we were to remove this pin, can click on the event, and I remove that pin by alt clicking on it and it will remove it. You can set it to run on server, reliable. We wouldn't technically need it if we're starting it up here though, because this is already running on the server, just if you were going to call it on its own. So now what we need to do is add a time for this. So we will set a random float in range. And we will promote this to a variable. This will be the spawn timer min. And we'll click it, Control W to duplicate it, spawn timer max. And let's give these some default values. I'll set them up for 65 seconds and 70 seconds roughly. I'm going to set the pickups to despawn after 60 seconds, so that should be just enough time where they're already despawned. And we're going to promote this timer handle, the return value, to a variable. So we'll drag off promote to variable, and we'll call this the spawn or spawner timer handle. And this will be the first time that we've done this in the video, but I'll show you how you can clear timer handles with this or check if a timer is already running. If you were to call this timer again while it's already running, I think it says in the tooltip, it'll reset the timer with the new parameters, which we want to avoid doing. So we'll make sure before we ever call this event that we'll double check that it's not already running or that we're okay with resetting it. Now let's create a bool and let's call that spawn item when timer starts. It's super verbose, but we could remove item to cut it down a little bit. I think people will understand what it is, and we want to also set these to be instance editable, everything but the timer handle. So let's drag out our bool. And if this is true, then we just want to go ahead and call spawn item. Now in spawn item, what we're going to do is spawn actor from class, and we are going to promote this class to a variable, and we will call this spawn, or we'll call it pickup class, because we're actually going to do something a little different here. I'll click on the pickup class, and instead of having it derived from the actor class, what we'll do is we will look up the pickup, BP pickup, we'll hover over that, and we will get its class reference. We will not get the object reference. So this is a reference to the class, and since we're already using it in the graph, it'll show us this warning that we're using it, so that's fine. We'll change the variable type. And of course that full screens. Okay, so now that that's done with, we'll have this set. And the reason why we do it this way is because when we click this drop down, you can see that we have all of our pickups right there, which is nice. It makes it easy, and we could spawn anything that we wanted to, technically, the way that we're going to set this up, but I'm just going to make it easy, and I wanted to show that to you guys. I figured you might like it. So what we will do is make sure it is valid class. We want to double check that we're not trying to spawn something with a null pointer or a null class. And if that's true, we will do that. And then from there, let's promote this to a variable. And let's set this to be a BP pickup. Rename that to pickup. And we're going to have to cast off the return node, cast to BP pickup. Alright, and then we are going to create a new function. And this function will be called onPickupSpawned. And we will add an input, and that will be a pickup. We technically don't even have to add the input, but we may as well. It won't hurt anything. We could just use the reference if we wanted to. So we will call that. We'll pass in our reference. And now this will allow us to override it if we need to do something when the pickup spawns. And we will also need to adjust our spawn parameters. So we need to set it to try to adjust location, but always spawn. And we also need to pass in the transform. So we will get our actors transform. And we will pass that in. As long as you don't go scaling this actor wonky, that won't be an issue, but I'll show you how to make sure that it wouldn't be even if you scaled it. So we'll pass that in and make sure our transform is 111. Alright, and then from here what we want to do is make sure that our pickup isn't already valid. So if we have a pickup, we don't want to spawn a new pickup. We want to wait till it's picked up, and then we will spawn a new one. And if it is not valid, sorry. And then we also want to set our timer to be looping. And now we can go back up to the start. And we could call start spawn timer. All right. Now we're going to need something to reset the spawn timer. That's something we haven't covered yet, and I think I mentioned it as well, for we're going to need something to destroy all of the coins. So let's go ahead and make an interface really quick. We'll open up our blueprints folder, we'll create a new folder, we'll name it interfaces. Inside that folder, we're going to create a blueprint class, and this will inherit from oh wait, sorry about that. Cancel, right click, we go to blueprints, blueprint interface. We will call this BPI reset. We'll open that up, and you can see we've got one function created, which is exactly what we need, and we will call this reset actor. We don't need to pass any inputs into it or any outputs. We will just basically use one function. This is also a use case example to show you how to use interfaces. So we will go back to our pickup spawner, go to our class settings, and you'll see we have an interfaces drop down. We have no interfaces implemented, so we will add a new one. So we'll click the drop down for add, and we will add the reset interface. Now we need to compile and save this blueprint, and then we can type out reset actor. So there should be event reset actor. That's what we're looking for. Now whenever reset actor is called on this actor, it will go through this event right here. And what we want to do is we'll delay for 1 second. We will check to see if we have a pickup that is valid. So we'll convert this to validated get. If it is valid, we will destroy it. Or actually, we will set the lifespan on it. Set that to 0.25. If it is not valid, we are going to start the spawn timer. Even if it is valid, that is actually what we're going to do. We'll do both, but if it is valid, we need to do one other thing before we start the spawn timer. And that is we need to set our pickup to be null. So this will basically respawn it according to our spawn timers from the time that the round starts, or from the time that the round starts regardless, or from begin play. It'll wait. We could also just set it up so it doesn't get triggered off begin play, and we could remove this and only allow it to get reset when the round begins, but I think I'm going to trigger this when the round ends, so it'll restart them then. And from there, whenever the actor despawns or whenever it's no longer valid, then it will allow it to spawn a new one. You could do some checks where you could potentially only try and spawn it once it's been taken, but this is a little bit more generic where you're not requiring too much information about the actor. You just need to know if it's there or not. Since it's a pickup and it gets destroyed when it's picked up, it's fairly straightforward. So let's create a child class, and let's also set up our default for spawn when timer starts to be true. Make sure our other defaults look alright. We have replicates ticked. Dormant all is also set. We don't really need this actor to replicate, but if you wanted to potentially spawn one of these during runtime, then you would need this actor to replicate. That is if you were to change any of these parameters per each actor. So what we can do here is we'll create a child actor of this, and we will call this, we'll do PS for pickup spawner, and then we will do health. And this will be a pretty simple setup. The one thing that we do need to do that I haven't quite covered is you need to make sure that you click your eye here and show inherited variables. You'll see them in your defaults panel on the right, but you won't see them on the left unless you tick that. So we can go to our pickup class and we could set that to our pickup health. And what we want to do here is override our function, and that'll be on pickup spawned. Since we know we're spawning a pickup health, we will cast this to pickup health. And what we can do here is set the health to be a random amount to add within range. So we'll do random in range. And we will set this to be 50 to 100. If you had already created individual child classes of the pickup health, you could just spawn those instead and then not worry about overriding this function. But I just want to show you a fun way to go about doing this where you can randomize some things. I'll set the armor. And this will be the exact same deal in between 50 and 100, and then we will set the helmet very quickly. And that will be random in range, 0 and 1. So either no helmet added or helmet according to how we set up the pickup healths to how they're adding the health. Now let's move on, and we need to really quickly add something that will allow these coins to despawn. And same with the health, because right now they're not going to despawn at all. So let's go to our pickups. Let's go to pickup health. Or we could actually go to our base class, pickup, and we will set our initial lifespan to be 60 seconds. That means after 60 seconds have passed, the actor will destroy. And that'll go for all of the child classes. You can see the pickup health is also set to 60. Now if we were to drag, save all really quick, drag one of our spawners, the pickup spawner health out. It's set to spawn when timer starts, 65 to 70 seconds. We'll have it spawn once at the beginning after the 2-second delay, and then if we were to wait 70 more seconds, we would see it destroy after 60, respawn after 70, but I'm not going to wait for that. So we'll create another one really quickly, and this will be called PS_coins. Oh, and I also forgot, if you were to replicate your health pickup, you would need to also flush net dormancy on this actor if you were to replicate these variables. These are not replicated, it's just being changed server side, and then we are asking about them server side, so that would not be required in this case. But if we go over to our pickup for the coins, it will be required in this case. So we'll go to onPickup spawned. We will also override our class really quick, or set our class variable. So when the pickup is spawned, we need to cast to pickup coins, and we need to call set coins. Okay, good, I did make this function. And we can actually promote this to a variable, and we will do random integer in range. And we will we'll promote these like I said. Promote coins min, Control W to duplicate coins max. Compile, we'll set this to 5, and we will set the max to be 50. Now I'm not going to use these during gameplay, or at least wasn't really my idea to use them during gameplay, but I guess you could make some sort of Mario mechanic if you wanted to, where people ran around the level picking up coins. So I mean, you could do, you know, something along these lines and have all your coins spawn in, and people can run over and pick them up, and you can see who has the highest score at the end of it. Or, you know, you can do a lot of different things with this, but just wanted to show the idea behind creating these spawners and how they would reset. Now, we also want to go into our pickup base class, and we'll implement the reset interface. So we'll go to our class settings, we'll go to the reset interface, and we will add that. Compile and save. And then we need event reset actor. And what we will do if this is called is we will set the lifespan to 0.25. And now we can implement the interface, or where we actually reset all of the actors, or we call to reset all of the actors within our game logic. So I'm going to close all these other tabs. I'm going to right click my game logic, close tabs to right. And I'm going to go into the end, round end. And right before we set it to starting, I'm going to get all actors with interface. And we will look up the BPI reset interface. And we could actually collapse this down to a function to make this easy. We will call this, oh, this is a great Unreal bug, reset actors function. And I'm going to add a delay after this as well for 1 second. We can go into this, and for each loop, call or reset actor message. There we go. Once again, return node, delete the variable, hook that up to the completed. And now we could, we're done with our reset interface. Now we could add in lives very quickly, player lives, for anyone that wanted to do a certain amount of lives per round or something along those lines. I'm not going to technically show you how to check if everyone has all their lives left, but we've come this far. I'm fairly confident that you could figure it out. You know how to look up all of the information as far as going through all of the players with the player array. You could also just get component or get component by class. So you could do this for each individual player, and you could look up information to see if they have any lives left, whether or not they're alive still whenever someone dies. And that would be your ideal way to go about that. But I'll show you how to add the variable and get started with it, and then that could kind of be your own work, or your own homework rather, if you wanted to proceed with that. So we will add a variable called player lives, or we'll just call it lives. And this will be replicated. And what we need to do here is we need to initialize with it first and foremost. So we'll set our lives when we initialize the component when the player loads in. You might have to do a little bit of work to determine how many lives to get them. If it's mid-round, you can maybe give them 1 or give them none until the round is done with, and then they won't spawn at all. But you'll have technically had to have spawned them once, so you'll probably want to go through a period where you spawn all of the players and initialize them, and then you don't go through the respawn loop for anyone that's missing the component afterwards. If they're missing the component, they don't respawn. But you do, in between rounds, there is a period where you respawn everyone regardless of their missing the component or not. And then you would probably also want to, during that first time, make sure that you set their lives, and you potentially want to remove it from the initialize altogether, because you would want to get their lives each time and then set it to the same thing. But less talking now, more showing. I'll get to it. So from the player state, we will get component by class. We will get the component player info. If this is valid, what we will do here is get lives. If this is greater than 0, so basically you would add this check in with your branch over here. Come on, nodes, cooperate. There we go. So you'd add this into your AND node. Put your is valid in front of all of this. If this is not valid, then you would know that it is their first time loading in, actually, which would allow you to spawn them much quicker if you'd like to. So we could just go ahead and move this around the branch that actually checks if they're dead or if they've been dead for a certain amount of time. We would potentially want to rework this a little bit. I'm going to create a new function just to show you guys really quickly what I mean. I don't want to destroy this example too much. So here's our new function. This would be our respawn loop instead. What we will do here is we will ask if they have the appropriate number of lives, only if it is valid. If it is not valid, then we will go through a branch that asks if they are dead for 1 and if they have been dead for X amount of time, which is fairly normal, what we were doing prior to. And if that's the case, we'll spawn them in. If it's not, then we won't do anything. So there we go, we're checking based on lives, and then we are determining whether or not we want to spawn them. Now I'm sure you guys are saying, well, we have to remove the lives when we spawn them. So if we go to onPlayerSpawned, we could, if we are adding it for the very first time, if it is not valid prior to, we could split this and initialize them differently. So what we could do in this case would be same sort of deal as before, but we will set them to their starting number of lives, or depending on how far they are into the round, we will reduce that number. And if we're coming through this, oh shoot, this is the wrong way. We'll set it that way. There we go. Otherwise, we will get lives. We will set them to -1. And we will basically subtract 1, and then they will set that number. We also need to make sure we pass in our game logic reference. Can't believe we missed that. That's bad, but up until this point, I think I've done pretty well where we're not missing any references. Maybe I did have that prior to. But this is how you would separate it out. Now it'll only spawn them if they have a certain number of lives available. If not, it will spawn them and they will get 5 lives the first time around. I'm going to go ahead and remove all of this before I send out the example, but yeah, this just about wraps it up. Last thing we need to do is create our function for event on player left server within our game logic. So let's go ahead and take care of that real quick. We'll add a reroute node. Right click, collapse to function. Still having that bug. And then we will call this player left server. And we will rename the input to player status. Go inside the function. And we will break the player status. We will say is valid on the player state. If it is valid, we need to get the component, get the player, or get component by class, player info, and what we need to call here is reset coins. We want to reset that to 0 when the player leaves, and we also want to check if it is no teams. And if that is false, we want to get team ID and call set team score. Actually, I believe we've already taken care of that. Yep, it'll take care of that within there. So we don't have to set the team score. And with that, it'll reset anyone's coins once they leave the server. It's possible that you could leave the server, and if you rejoined quick enough, you would have your coins when you rejoined, but you'd be dead. So your team could potentially hit a condition where they could win, which I don't think players would want. So we'll go ahead and make sure that we reset that if the player leaves the server. And that definitely wraps everything up now. Congratulations, guys, if you made it through this entire video. I talked quite a bit and showed off a lot. I really hope that you guys picked up on quite a few things from this, especially from the player info component. I think that was one of the bigger things to touch on, as well as the base classes. But from here, I'm going to double check my definition real quick. I'm going to call this coins testing map. We'll save that. We will go to window Pavlov workshop. I'll sync my metadata and I will deploy this as my initial push. Thanks. I'll see you guys in game. Alright, so we've got the game mode loaded up and we have just spawned in and it looks like we have 0 coins. But don't worry, it's not broken. We just forgot to set the initial coin value, so we're still getting them added to the player score. So let's test a couple things. Go to the buy area first. Buy a pistol. That seems to work as expected. And we will walk over that. That one didn't give us helmet, but it is all random, so we'll have to wait and see. I've tested this before. I know it will give you the helmet. So we just didn't have the right RNG. So we'll test the teleporter, and that seems to be working. Now, as you can tell, our text is going off of that widget, so we'll have to adjust that. We'll test the boost pad very quickly, and you can see we are flying around the map pretty quick. And all of our coins must have just hit their despawn timer. Yep, because it just respawned. So now we'll test the jump pad. And you can see with low gravity we're flying pretty high, even though we have a somewhat low boost value. You can see compared to how fast our mags are falling. So now we'll grab the coins that we need to win the game mode. So as you can see, it displays the winner. Kills all of the players, resets all the spawners and the coins on the level, and there we go. Now let's test it real quick in deathmatch. That's another thing we need to do, is we need to reset the team score, but it won't create a bug where they would win again. It's just a visual bug where we haven't updated the score yet. So let's show deathmatch really quick. You can see the timer is adjusted for deathmatch like it should be. And there we go, the win conditions met for TDM, or for deathmatch rather. Alright, so thank you guys. Let's get back to the editor, fix those bugs. Alright, now that we're back in the editor, the first thing that we need to do is fix these scoreboards so the text isn't too long. So one easy way to do that is we could just change the font size of the text. So we'll navigate to our widgets folder and open up the widget blueprint winner. We will select this text up top and we will take the size down to 38, should be plenty at that point. Next, we need to update the score when you spawn. So this should be also a fairly easy one to do, and potentially just forgot to mention this during the video, but once we get our score initialized, we need to also call set player score, and we could do that after the init player client. And lastly, when the round ends, we need to clear out the team score, and that should also be a fairly simple fix. So all we need to do here is get team score. We need to get team score for team 0, and we need to get the team score for team 1. And technically this would get fixed when they spawn. It should go through it. Oh, and we're also not updating the team score when they spawn. Another thing I have to do, so let me do that. So the one thing we want to do is we'll collapse this down to a function, and we'll call, oh, whoops, it doesn't like that. Do it this way where they're hooked up. There we go. and this will be called reset team score. So we'll pass this in right when we do reset actors. We will check to see if no teams is true, or false rather, if we have teams. And if we do, we will get team 0 score. We will set team score. Oops. Set team increment team score. There we go. We want to multiply our score by -1. Do the same thing, and we will manually enter our team ID here, team ID 1. Multiply it once again by -1, pass our score in, and we will add our return node and remove the variable from it. So off of our true, we will go to our return node. We're not going to do anything if it is a TD or free-for-all match, because they won't have team scoring. And then, as I mentioned, when the player spawns, we will also need to check their team score. And one thing that I want to do is, if a player spawns in, I don't want that to be a win condition for a team. I just want that to set their team score, but if they get that, if they earn the 5 extra coins that they need through someone spawning, I don't want that to allow them to win. It may look confusing from the scoreboard, but I think it's a good move from a gameplay perspective. So what we will do is go over to our player spawn function, and we can call set team score. And what we want to do here is also once again check if there are no teams, and that is set to false. And if that is set to false, we will pass in our team ID, oops, from our player status. And to clean this up a bit, we will get the player status, we will break it. I'll drop down the struct, get the team ID, pass it in, and then I'm going to click, with the struct clicked, I can go up here in the right hand details panel and hide unconnected pins. So it'll only give me the one that I need. And I will place this at the end of this function right before our return node. All right. And actually, I hate to do this right after we set this all up. We'll just copy paste that, or we'll cut that out, and let's just go in our player info component, and we will do that when we initialize. I would like to make sure to ensure that our coins are actually set before we go through and do this. Set team score. We will get the team ID, pass it in. Alright, and that fixes all of our bugs. We are pretty much good to go at this point. I'm going to package everything up and I will redistribute it as a plugin. If you are just going to download the plugin, you have to move everything inside of your UGC folder for it to work. If you have any issues, feel free to contact me on the Discord, Mark Day. Or you could also leave a YouTube comment, but I'm a lot slower to get back to those. So I appreciate it, guys. Thanks for taking the time to watch this video. Let me know if you have any requests for the next one, or if you run into any issues along the way.